everyone, welcome to today's live project demo. We will be talking about another amazing Kubernetes project called Create Kubernetes Manifest. It is the key to Kubernetes deployments. Kubernetes manifest files are something that you're going to be learning all about in today's project, and it comes through as part 3 of our 5-part Kubernetes with AWS series. Now, you've learned how to prepare an app's backend for deployment in the previous project. If you haven't done that project yet, that's okay, because you'll go through the key parts of those projects at the start of this one too. Now, that previous project was about how to prepare an app's backend for deployment. What we had to do was we pulled some code from GitHub and created a container image out of it so that you can use that to deploy an app, to deploy that backend later on in this series. Now we're getting very close to actually deploying that backend, and in this project, we'll be creating files in your project that help Kubernetes with understanding how it can deploy your app. Now you have this container image, Kubernetes is now going, okay, I've got this container image that I can deploy. How do you want me to do this? How many containers do you want me to run? Should I be doing some special networking settings? Should I be doing some special security settings? What should I be doing to make sure that I am deploying this app in the best way possible? We will be talking about another amazing Kubernetes project called Create Kubernetes Manifest. In this project, you repeat the last 2 projects of this series. The new item is the manifest files that you can see at the bottom of this diagram. Now, let's talk about the top 2 parts first before we really dive into what's new in this project so that we have a good recap of what's really going on in your entire solution here. What you do in part 1 is you deploy this EC2 instance, and then you equip it with a tool called EKS to create a Kubernetes cluster, which is this thing over here. A Kubernetes cluster is a group of containers running a containerized application together. Once you've created your Kubernetes cluster, your group of containers doesn't have an application to run yet. It's just this group of containers that are saying, what would you like me to run? In part 2, you're saying, I have something for you to run today, but let me get it ready for deployment with Kubernetes. You need to actually give your Kubernetes cluster a containerized application. This containerized application is something you need to create using the code that your team member has prepared. So they've prepared that backend application code, they've put it onto GitHub, and your job is to pull the code from GitHub into your EC2 instance so you have a local copy of their code. And once you have a local copy of their code, you can use a tool called Docker to build a container image. Just think of it as a template for the perfect container for running this backend application that your team members created. Although EKS is capable of running container images that live locally, best practice is actually for you to push that container image onto something called a repository. Just like how code has repositories like GitHub, which means you can push your code up into somewhere in the cloud that can track different versions for you, same goes for container images. So that there's a place where you can track all of the different versions, all of the different changes you've made to that container image. And it's also very easy for a Kubernetes cluster to pull an image from ECR because they're both AWS services and their integrations are very strong with AWS's infrastructure in the background. So that wraps up the first 2 parts of this project series. 1, you've created your Kubernetes cluster, a group of containers that's capable of running this containerized application. And then in part 2, you set up what application you want your Kubernetes cluster to run. Part 3 is this juicy part here that says, well, you have your 2 key ingredients. Let's go deploy that app backend. One of those key steps is to create something called a manifest file. And these manifest files are basically the instruction sheets that tells Kubernetes how it should deploy your application. Because deploying an application comes with a lot of different settings that you need to sort out. If you've done the project on deploying your Docker container image with Elastic Beanstalk, you might remember that you've had to go through many different steps that says things like, oh, my instance should have this type, you should have a public IP address, here are some security settings, here's how I want to monitor it, here are some networking settings. There's so many different things you need to think about when you're deploying an application. And manifest files is our way of telling Kubernetes our preferences and our settings. This project details 2 manifest files that you need to be creating. One is called the deployment manifest, and the other one is called the service manifest. The deployment manifest is about the exact details of what you want to deploy, which is the container image. And then your service manifest is going to say, hey, when you deploy the backend that I've given you, I want you to make sure that it can be accessible through these ports. I want you to expose my application so people can access this backend that I've created. So these 2 really work together to create a very successful deployment that your users can see and access. So it's very exciting. Manifest files are a very key tool because it's how Kubernetes will know how to deploy your application. All right, so with that introduction, let us get started with the project today. We will be talking about another amazing Kubernetes project called Create Kubernetes Manifest. In this project, you repeat the last 2 projects of this series. The new item is the manifest files that you can see at the bottom of this diagram. Now, let's talk about the top 2 parts first before we really dive into what's new in this project so that we have a good recap of what's really going on in your entire solution here. What you do in part 1 is you deploy this EC2 instance, and then you equip it with a tool called EKS to create a Kubernetes cluster, which is this thing over here. A Kubernetes cluster is a group of containers running a containerized application together. Once you've created your Kubernetes cluster, your group of containers doesn't have an application to run yet. It's just this group of containers that are saying, what would you like me to run? In part 2, you're saying, I have something for you to run today, but let me get it ready for deployment with Kubernetes. You need to actually give your Kubernetes cluster a containerized application. This containerized application is something you need to create using the code that your team member has prepared. So they've prepared that backend application code, they've put it onto GitHub, and your job is to pull the code from GitHub into your EC2 instance so you have a local copy of their code. And once you have a local copy of their code, you can use a tool called Docker to build a container image. Just think of it as a template for the perfect container for running this backend application that your team members created. Although EKS is capable of running container images that live locally, best practice is actually for you to push that container image onto something called a repository. Just like how code has repositories like GitHub, which means you can push your code up into somewhere in the cloud that can track different versions for you, same goes for container images. So that there's a place where you can track all of the different versions, all of the different changes you've made to that container image. And it's also very easy for a Kubernetes cluster to pull an image from ECR because they're both AWS services and their integrations are very strong with AWS's infrastructure in the background. So that wraps up the first 2 parts of this project series. 1, you've created your Kubernetes cluster, a group of containers that's capable of running this containerized application. And then in part 2, you set up what application you want your Kubernetes cluster to run. Part 3 is this juicy part here that says, well, you have your 2 key ingredients. Let's go deploy that app backend. One of those key steps is to create something called a manifest file. And these manifest files are basically the instruction sheets that tells Kubernetes how it should deploy your application. Because deploying an application comes with a lot of different settings that you need to sort out. If you've done the project on deploying your Docker container image with Elastic Beanstalk, you might remember that you've had to go through many different steps that says things like, oh, my instance should have this type, you should have a public IP address, here are some security settings, here's how I want to monitor it, here are some networking settings. there's so many different things you need to think about when you're deploying an application. And manifest files is our way of telling Kubernetes our preferences and our settings. This project details 2 manifest files that you need to be creating. One is called the deployment manifest, and the other one is called the service manifest. The deployment manifest is about the exact details of what you want to deploy, which is the container image. And then your service manifest is going to say, hey, when you deploy the backend that I've given you, I want you to make sure that it can be accessible through these ports. I want you to expose my application so people can access this backend that I've created. So these two really work together to create a very successful deployment that your users can see and access. So it's very exciting. Manifest files are a very key tool because it's how Kubernetes will know how to deploy your application. All right, so with that introduction, let us get started with the project today. Cool. By the end of this project, you will set up a deployment manifest that tells Kubernetes how to deploy your backend, and then you'll also set up that service manifest that tells Kubernetes how to expose the backend to your users. If you're feeling a bit new to these terms, just know that we'll be going through all of these terminology bit by bit throughout the project. You're not expected to know what this means already. You're expected to learn about it through the project. The secret mission is great. You get to dive into the details of manifest files to discover some new learnings. The more you understand these files line by line, the more you build your understanding of Kubernetes architecture and how Kubernetes works in general. So, what is a Pro project? Being a NextWork PRO member, you get access to an exclusive selection of advanced projects. Pro projects are designed to let you tackle harder challenges and build more complex solutions. The diagrams are also getting busier and busier, and that's because Pro projects integrate more tools. Kubernetes is one of the many in-demand skills in the market, but expect more skills like Terraform, multi-cloud architecture. Eventually, you build towards solving real-world problems companies are facing. We will no longer assume you're a beginner to AWS. Please come to these projects with at least 4 to 5 NextWork projects or equivalent that you've done before, so that you've covered some core AWS services like EC2, VPC, CLI, S3. Make sure you have a good understanding of these so that when you come into a Pro project, it wouldn't feel too intimidating that we're jumping into the deeper end of these basic services. All right, as always, we're going to be using the high-touch version of this project. We're going to be recapping what we're actually here to do today before we get into the weeds of it. In this project, we will set up manifest files because they are a key part of the Kubernetes deployment process. Whoa. Manifest files give Kubernetes the instructions on how it should deploy our containerized application. Amazon EKS is not AWS free tier eligible. AWS charges 10 cents for every single hour that EKS is running. To minimize costs, delete all your resources today. Be mindful of different instance types that can pop up when you're doing these projects. T2.micro is free tier eligible. Other instance types are not. So if you're choosing something like T3.micro, for example, you will likely get charged. These charges usually don't become a material thing in your bill unless you're running it for hours and hours and you leave it running. Deleting resources at the end of the day is really going to help minimize costs, if not push it down to zero, because some resources don't start charging until they've detected that you've been using it for maybe like half a day, a full day, 6 hours, 3 hours, whatever it is. Often the time it takes you to complete this project is shorter than the time it takes for AWS to start charging you for some of these resources. Please delete them. Delete everything. You will always be able to restart these resources again. Let's get started. We're setting up our environment. If you've done the first 2 projects of this series, I hope You'll be very familiar with these steps by now. Challenge yourself. You can pause this video and give these steps a go without any guidance to see if you've really gotten a grasp of it. We found that repeating steps has really helped with getting all of these instructions becomes ingrained in memory or ingrained in your understanding of why we do these steps. Now, we'll launch an EC2 instance to set things up. This EC2 instance is where we'll send commands to EKS and other tools, and then create the EKS cluster. EKS, Elastic Kubernetes Service. If you like a little refresher, it's a service that helps you run Kubernetes on AWS. Because if you try to do everything by yourself, Kubernetes is an open source tool you can download, install, and use locally. Trust me, it can be quite time consuming. All the setup you need to run a Kubernetes cluster is intense. You need to configure a lot of stuff on your own. So most people use platforms like EKS to minimize these manual tasks, and also it really helps you with integrating Kubernetes with other services as well. So in this step, we will set up for our project by launching an EC2 instance, which will be our command center for the day. Using the EC2 instance terminal, we'll be installing EKSCTL and launching an EKS cluster. Please log into the AWS Management Console as your IAM admin user, and we'll get to kick off. Alright. Now I'm already in my instances page. If you're seeing your main page, don't forget that you can just navigate into the EC2 console using the search bar, and you can click into instances. That will jump you straight into this page. Otherwise, if you're seeing the main dashboard, you can always click on instances on the left-hand navigation panel. So we're here now. Let us launch our instance. So we're going to click on launch instances, and we're going to name our EC2 instance something very straightforward, NextWork EKS instance. For the AMI machine, the Amazon machine image, make sure whatever you choose, it's free tier eligible, because we don't really need to go beyond the free tier limits. We'll only be spending on the parts where we really need to be spending, which is like running an EKS cluster. Make sure you're choosing the free tier eligible instance type if you've done the previous projects. We don't need to use a key pair for this project because we'll be using another tool called EC2 Instance Connect that helps us directly SSH into our EC2 instance just over the browser without really needing to download or install things like key pairs. For the network settings, we're keeping the default security group. We don't need to touch anything. The default security group lets in SSH traffic from literally anywhere, so any kind of IP address, which technically exposes your EC2 instance to a lot of potential traffic and a lot of potential connection over SSH. This isn't best practice for that reason. You'd want to protect traffic going into your EC2 instance as much as possible when using Instance Connect. IP address EC2 Instance Connect uses can vary a lot depending on which region you're using. You can allow SSH traffic and make it custom, find EC2 Instance Connect's IP address, and continue. That's totally an option for all of the pros that are wanting to make their solution extra secure, but it's not required. Let us launch our instance. Launching an instance is such a straightforward process if you need it to. And then if you also want it to be a more complex process because you have a lot of configuration needs, EC2 is one of the most advanced services in AWS, so it has the capacity to do that as well. It is already running. It's actually just initializing. So we'll have to wait before we can connect. Shall we give it a go and see if we can connect already? Okay, we can start establishing the connection. That was fast. We're connected to our EC2 instance. We've launched a virtual server in the cloud, figured out a way to communicate with it. I think that's awesome. I think it's really cool we can do that. With that set up, What's next is to install EKSCTL. Let me run the command for installing EKSCTL. And EKSCTL is a command line tool that lets you work with Amazon EKS in the command line. Instead of having to go into the console to work with Amazon EKS, you can now do things like create clusters all within the terminal because of tools like EKSCTL. It's very, very good. Verify if we've installed it by running something called checking the version. And checking something's version is always the go-to way to see if you've installed something. You know, whether it's EKSCTL, whether it's Docker, it's Git, something else, check for its version. It's just the go-to way to figure out whether you've actually installed it or not. Okay, cool beans. And if you don't see that version number, by the way, I'd recommend checking out the command you use to install it. See if your terminal actually responded with any errors. If it didn't, and if you can't check the version, ask the NextWork community. We can help each other out. Cool beans. If you've done the last two projects, you know what's coming. It's about giving your EC2 instance the permission to interact with AWS services using an IAM role. If you've created that IAM role before, skip ahead to the next part of the step. If you haven't created it before, here are the steps in this guide. This console might already be set up with the IAM role. If you need to access the step-by-step guide, or check out the project demos for the first two projects, which walk you through these steps. If you've already created the instance role, double check by finding it in your console and checking if it has the correct permission policies. For myself, it looks like it doesn't have the right permission policies. I'll delete this and then we can go through the steps for creating that role as if we're brand new. Very good. So to create this role, make sure you're in the IAM console. Over here, you can also click directly on roles under these options so that you're in the roles page like this. When you're in the roles page, you can create a role. Under the trusted entity type, make sure that it's an AWS service that you've picked so that you can now give a service like EC2 the permission to get access to your AWS services. Cool. Why do we need to do that? An EC2 instance doesn't have permission to do anything in your AWS account yet, but you need it to have that permission because we need to use our EC2 instance to create our Kubernetes cluster with EKS. If our EC2 instance doesn't have the permission to do that, there's no way we can set up that EKS cluster. So let's give it EC2 instance. That's going to be our use case for this role, and select next, and we're going to provide it with administrator access like this, which again is not best practice. I know it's not best practice because you usually want to limit access to whatever the EC2 instance actually needs. But in this case, we're allowing administrator access so that once we get to the full solution and we understand all the services our instance needs, we can work backwards and take away access. If we were to go through this entire project using best practice, we'd follow the principle of least privilege, which means we give our EC2 instance no access until we keep running into permission errors, and then we have to come back here and apply a new policy one by one until our EC2 instance gets all of the permission it needs to run the specific commands or do the specific tasks. To save ourselves a lot of that time and a lot of that effort, we'll just be choosing administrator access from the get-go. And yeah, our role name. That role name is going to be NextWork EKS instance role. This role will grant an EC2 instance administrator access to your AWS account. Let's create that role now. We've created the role, and we can now attach that role to the EC2 instance. So what that means is We've created the role, the permission to do something, but right now the EC2 instance hasn't received that role yet. So currently it still has the same level of access it always has, which is none, until we wrap that role around our instance. So our instance actually has the permissions that we've just set up. Under Actions for our EC2 instance, select Security and modify IAM role. Modify IAM role. The IAM role we're going to pick is NextWork EKS instance profile, which is the profile we set up just now. Alright, so we'll update our IAM role. EC2 instance has administrator access to our account. That means we're ready to come back to EC2 Instance Connect and run the command to create a cluster. The command is very simple, all thanks to EKS CTL. If we were using tools like AWS CLI, we'd have to run 20 commands to set up a cluster. But thankfully, EKS CTL has made it easy and boiled it down to just one single command. So let us run this command and making sure that we replace your region at the very last line with the region that we're using for this project. Check the region by clicking on the region selector on the top right corner and taking note of the region code. Only the code. Mine is US East 2. Make sure to check which one's yours, the one that's highlighted blue for you, because you want to make sure that the region you're putting in here is exactly the same region as the region you've used to create your initial EC2 instance, so that everything is in the same region. Once it's off, it's off. Off it goes into creating that EKS cluster for you. Creating that EKS cluster can take some time. It's about 15 to 20 minutes sometimes. So there are heaps of stuff that we can do in the meantime. To set up today's project, I launched a Kubernetes cluster. Steps we took: granting our EC2 instance permissions over IAM, and installing the EKS CTL command line tool. We created the cluster using the EKS CTL create command. Next, pull the code for the backend of the app. Now that our EKS cluster is spinning up, let's find the app backend that we want to deploy. Your team member has pushed the backend code into GitHub already, so we'll just start there. If you're new to backend, just know that backend is the logic or brain of an application. It's where your app processes user requests, stores and retrieves data. If you're new to the backend, highlight and select Simplify to understand it a little bit better. Yeah? So for example, Simplify has explained it as the part of a website or an app you can't see, like the engine of a car. It makes it work, although the bells and whistles are what really makes it beautiful from a visual perspective is considered the front end. But yes, the beauty of backend is that it handles the data and logic that makes the website function. So we can think about different examples here. For example, backend code can be about figuring out a database and how you log in to NextWork. How does your page load with exactly what projects you've completed? How does it remember all of the questions you've answered in the documentation you've created? It's because the backend, the brain of the application, can actually connect your credentials, your username, your email, and your password with a record in our database that contains all of that information about you or the things that you've done to create your documentation so far. So that's a great example of the backend. In this step, we will pull the backend code for our application from GitHub. We did not write the backend code. That was written by our team member. We're creating a local copy of their work. While your EC2 instance is creating that EKS cluster, we don't need it right now. We can head back to the EC2 console to set up another connection using EC2 Instance Connect. You can set up separate connections with the same instance. It's like multitasking for your EC2 instance. It can run commands from 2 different connections at the same time. Don't worry, running more commands from this terminal doesn't stop any progress in the other. So your EC2 instance is capable of doing both at the same time. Now, with this new connection that we have to our EC2 instance, it means that we can just get started with pulling our team members' backend code without having to wait for that cluster to be created first, because you don't need the cluster in order to pull the backend code. So in that new EC2 Instance Connect tab, we'll run the commands to install Git over here. I don't think I copied the code properly. Maybe I need to refresh my tab. That didn't paste quite well, did it? Let me try copy the code one more time and try paste it. If it doesn't paste, I guess I'm left with manual typing for the commands for this project, which will be a bit of a shame, but that's okay. Oh, it could be a connection error. That took a bit of time to connect. Maybe where I'm at right now doesn't have the best connection to servers in Ohio. I wonder if that's the reason. Alright, but at least we can paste our commands now. That ran quickly, so no more concerns about the speed. We've just installed Git, the version control system that tracks changes to our code. Now check for its version so we can see that we've installed it properly. I have a version number, which is great. Next, we'll configure Git. We'll run the 2 commands here that helps you with setting up your local Git identity. We don't actually need to replace these placeholder values. That's a secret for me. In order to run these commands, your local Git identity is not too important in this project today, so you can always just enter it. I think I did something funny with my keyboard. Once you've pasted the command, you can press enter and it will automatically just log your name as NextWork and your email as this, and that becomes your local Git identity, which is totally okay. Cool. And with our Git all set up properly now in our EC2 instance, it means that we're ready to clone our team members' repository. Cloning is about creating that local copy of someone's code that's stored in the cloud, for example, in GitHub. It doesn't actually have to be in the cloud as long as it's remote from your machine. When we say something is in the cloud, it can refer to the fact that it's being hosted by a cloud service provider. Some people will take the term to mean that way. But let's say it's actually just on a network that's not hosted by a cloud service provider. It's in a company's private network that's technically stored remotely too. So when you are cloning someone's repository, you're basically saying, I can see your code is stored remotely. Let me copy it and have a local copy of what you've created in my workspace as well. You might notice that in my last project demo, if you happen to watch it, about the second project of this series, we gave you the commands on how to clone a repository. We've changed the instructions so you can actually visit the GitHub repository yourself and learn how you can find the URL for cloning a GitHub repository. So in a new tab, come check out your team members' hub repository. Okay. You'll land right here once you've arrived at their repository. And this is the repository that contains all of the backend code that they've prepared. You can snoop around and see what's inside the backend that they've created, or you can go straight into the next part for this step, which is to copy the URL that is a reference to this repository. Once you've copied this URL, run it in a new tab, and you can see this URL is a reference to the backend repository your team member has created. You are ready to run the command to clone this repository, which means make a local copy of all of these files. So let's head back to EC2 Instance Connect and run the command of clone. Paste the URL. The cloning is happening. It seems like it's taking a bit of time on my end, which is okay. We'll let it take its time. And in the meantime, we can learn what is. This is a GitHub repository that a team member created. Once you've cloned the repository, get a local folder in your EC2 instance. In that local folder, you should see a copy of each of these files, which is pretty cool. My EC2 instance is still taking its time with this command, so I'm going to refresh it to make sure nothing's gone wrong. Okay. Let me paste the command once again. I should be running git clone and then the URL. Cool. I get an error that says the destination path already exists and it's not an empty directory, so it's already been downloaded. I didn't need to clone it again. To check, you can also navigate into the directory. So you can use CD to navigate your terminal inside this directory. So I'm going to say, hey terminal, let's go inside this folder. And we're now inside this folder. And I run the command ls to list all the items inside. It's really cool to see that exact match between 4 files here and the 4 files here. We've successfully created a local copy of our team members' code. How did you get the code for your project's backend? We retrieved the backend that we plan to deploy by cloning it from our team members' GitHub repository. Backend is the brain or the logic of an application. For example, how an app stores, retrieves, and processes data. Cool. So we've pulled the code from our team member. We know exactly what we are ready to deploy now. But as we've mentioned in the introduction, Kubernetes doesn't just deploy anything. Kubernetes is more selective. Hey, if you want to deploy an app with me, you got to make sure that app is in a container image. And that's because Kubernetes, at its core, is a container orchestration tool. Unless your application is in containers, it wouldn't be able to orchestrate it. It wouldn't be able to manage it and run it in a very organized way for you. So that's why in the next step, we're building a container image for the backend. Sometimes you might be thinking about how you can explain why. A great way to explain it is to mention that Kubernetes needs to pull the app from a container image it can access. A container image is like a blueprint that contains all of the instructions, code, libraries, and dependencies that you need to run the application. If you're new to containers, note that the container is the running instance created from that image. The container image is the blueprint that contains all of the instructions, and the actual container itself is a running instance that you bring to life using a container image. This means a container image is like that template that Kubernetes will use to repeat again and again and again the creation of multiple containers that are identical to each other. Cool. And that's how we ended up here in our diagram. So now that we know that EC2 instance has pulled from GitHub, it has the code to build a container image of the backend application. And why are we doing this? It's so that Kubernetes can actually run our containerized backend. Otherwise, Kubernetes won't be able to run our backend application if it's not containerized. In this step, we will build a container image of the backend pulled from GitHub. Because Kubernetes needs to pull a container image that it can access to deploy any application. Very nice. Done. Let us get started with building that container image. Notice how that container image is actually called a Docker container image, by the way. So if you haven't picked up on it yet, what that means is the tool we're using is called Docker. Do we have that tool? Nope. Which is why the first step is to actually install the tool that's going to help us with building the container image. Let's run this command that helps us with installing Docker. Off we go, installing Docker. That takes a little bit of time, but that's okay. In general, you'd use Docker to create containers and container images, while Kubernetes is the coordinator, orchestrator of multiple containers running the same or related applications. Think of Docker as a creator and Kubernetes as a coordinator. Sometimes people mention Kubernetes creating containers to run these containers in clusters. You might hear that Kubernetes creates the cluster or containers. What's really happening under the hood is Kubernetes is employing the help of containerization platforms like Docker so that it can create those containers. The actual engine creating the containers is Docker or other platforms, even if you see in a sentence that Kubernetes created the container. Okay, I thought I'd put that out there in case you ever get confused on whether or not Kubernetes can actually create containers or not. Cool. So once we have installed Docker, we're going to start it up by running this command. Once you've started, Docker is ready to create container images with you. It's no longer sleeping. It can actually do some work now. But in order for us to get it to do some work, we need to make sure that our EC2 user has the permission to do that. To confirm which user you're using in the terminal, just run that command called whoami. And there you go. The terminal says, oh, you're EC2 user. It's not the IAM user. It's not this thing here that they're saying you are. They're saying that you're something else called the EC2 user. Your EC2 instance user is completely different from your AWS account user. Think of it as having a separate login for each server, and your EC2 instance credentials are not directly tied to whatever account credentials you have here. That's kind of like the reason, it's kind of linked with the reason why your EC2 instance still needed administrator access separately, even though you're accessing it from your IAM admin user. When you launch an EC2 instance using an AMI like Amazon Linux 2023, the AMI will automatically set up the EC2 user for you and make it your default user. So when you're going into EC2 Instance Connect and you connect with your instance, you automatically are using the EC2 user. Your user doesn't have access to Docker, The reason why we could run these Docker commands in the past is because we added sudo to the start of our commands. But adding sudo to the start of your commands is not the sustainable way to do things, because it means that you now have the pressure of putting sudo at the start of all of the relevant commands. If you slip up once, it can stop a process, it can cause an error that delays things, which is not ideal. So let's find a different way to do this, and it is to add EC2 user to something called a Docker group. So we'll run this command. Very nice. Once we've added it to the group, our EC2 user has permission to run those commands. We can restart the session to refresh credentials. When it's restarted, verify by checking what groups your EC2 user belongs to. Run this command in your terminal. Groups EC2 user. You can see Docker listed as a group. That means EC2 user can run Docker commands now, and you no longer have to use sudo. If you're feeling like that was a bit much, don't forget that we have more detailed explanations in the respective parts, in the respective projects that represent step 1, step 2, step 3. So if you wanted more explanations around step 1, check out project 1. If you want more explanations around pulling the code, building the container image, check out project 2. Well, we're back into our EC2 instance now, and can jump back into the application directory by running the command cd again. So we are proving that we've entered into the folder that contains all of our team members' backend code. We've run the command ls, listing all the files and all of the folders that is inside the folder that we're currently at. Since we're inside NextWork Flask backend, you can see we have all 4 files our team member did. This confirms we're at the right place for building the container image. Let's copy the code for building the container image and run that here. Small quiz: why do we need it to be in the exact same directory to build our container image? The reason for that is we have a full stop here at the end of the command. Having a full stop at the end of the command is saying the Docker file that Docker needs to build the container image is right here. You need to exit this folder. If you are seeing errors around Docker can find the Docker file, just know that maybe you just need to be at the right folder to run the command. Make sure your Docker file is visible when you run ls. A great success on our side. We got to build the container image. You can see that it's already been named. Very good. No errors here, so we can conclude that as a success. Once we clone the backend code, we built a container image because Kubernetes requires apps to be in container images to deploy them. I use Docker to build a container image of our backend. Very nice. Step 4. Feel free to pause and take a break. We've been going at it for about an hour now. So in step 4, we're here to push your container image to Amazon ECI, which is a repository for container images. Container registries like Amazon ECI are storage spaces for container images. Once you've built your container image, you use a registry to store it so it can be accessed by Kubernetes and other services. This setup is the standard way for deploying containerized applications with Kubernetes. They really wouldn't have access to it unless you had some sort of manual way to send that image to their local computer. Now imagine that's multiplied by 20 people. You have a team of 20 people and all of them want access to your container image, so you give them a local copy each. Build as many containers as you want from that image. Everyone builds dozens. And all of a sudden you're like, oh shoot, I need to update my container image. Maybe I need to change a certain command. I want to add a new functionality. So you change your container image and it becomes your job to make sure that now all 20 of those people in your team are using the updated version. An ECR, a container registry, is the storage space in the cloud that lets you, instead of storing your container image locally, store it somewhere where other people can pull the latest version automatically. You wouldn't have to manually change which version they're using on a one-on-one basis. In this step, we're just going to be storing the container image we've built into ECR, which is the repository for container images. Well done. Yeah. In this step, we will use ECR, Elastic Container Registry, as the storage space for our container image. This, using a container registry, is a much faster way to make sure team members' apps are pulling the latest version. That we can create the Amazon ECR repository using a command instead of having to click through the console. And the reason for that is because using a command to create a repository is a great way for you to learn about how you can just start to script and automate more and more of this process. So we will paste that command into our EC2 terminal. Our terminal gives us some JSON data back. When you see that JSON data, it means that it's been created. And here are all the details about your new ECR repository so that you know how to find it. If you're like me and you see interesting little colon at the end here, just know that you can quit that by typing WQ or just Q. You get taken back to your normal terminal mode. We've created the repository now using a single command that was very fast. If you'd like a recap of why we're using the registry, this is a great place to learn about it too. Cool. So this terminal's response does confirm that our ECR repository has been created. It's really ready now for you to push some new tab, search for the ECR console. So you can just type in ECR like this. And once you have opened it up, here is your registry for all of the container images that you've built that you wanted to share. Confirm you see a new repository called NextWork Flask backend. If you see this, congratulations, you've successfully created the repository using code run through the terminal. If you can't see this, make sure you're using the correct region and that your CLI to use the correct region, or really configured your EC2 instance when you launched it to be using the correct region. Cool. But now that it's live, it means that it's ready for us to start using push commands to push the container image that we've built into ECR, into the registry. Great. So let's click into that new repository we've created. It's looking pretty good. And there's that bright orange button here that says View Push Commands. And these are the commands that will help you with pushing the container images you've built into this repository. So we'll start by copying that first command. It's a bit of a copy-paste job throughout. Copy that first command and you can run it straight away. If you'd like an in-depth explanation of each of these push commands, check out the previous project in the series. We also have a dedicated project on ECR. It's called Deploying an App Across Accounts. It's good. That first command is running. Good. Head back to our ECR console window. Skip the second one. It might look familiar. You've already run this command to build your backend application, so you don't need to build it again. What we'll be focusing on is now that the container image is built, we'll tag it so that when we push it, it's really easy to refer to which container image are you pushing? Is this one or this one? And you can just say it's whichever one I've marked as latest. Since our image has been marked as latest, it is marked as the thing that we will want to push into our container registry. So let us tag what we've built with the latest tag. Once it's tagged, we will run the command to push the image into ECR. Up into ECR it goes. Very satisfying. You can check the ECR repository to see it is saved in here now. Woo! Looking good! Did you see the way the image went from 0 to 1? That is always such a nice feeling. We've successfully pushed the container image of the backend app into ECR. We've done a lot for setting up Kubernetes deployment. These steps prep us for the new steps for this project, which are about the manifest files. We're about to go into our first one. Oh. We pushed the container image to a container registry because this helps us establish a single source of truth for the latest version to push the image to ECR. We ran the push commands that tagged the image. Welcome to new territory for this project. Set up your app for deployment. So with our image now very safely in ECR, we're really ready to deploy that application to that EKS cluster that's already going, that's ready for a containerized application. We'll use something called Kubernetes manifest so that we can tell Kubernetes how we'd like to deploy our application. Otherwise, Kubernetes wouldn't really know. There are just so many different ways it can deploy an application. Giving Kubernetes the instructions on how it should deploy your application is super key. Okay? And it's just like how a Docker file will tell Docker how to build a container image. This thing. A Kubernetes manifest tells Kubernetes how to run your application in a cluster. They define the desired state of your app, including which container images to use, how to make your app available to end users. That's the service manifest, and this is the deployment manifest at work. Cool. In this step, we're creating our first deployment manifest that gives Kubernetes instructions for deploying a containerized app. In our case, we wanted to deploy our containerized backend to the Kubernetes cluster that's already spinning. To create the Kubernetes manifest files, start by creating a new directory from your instance's root, name it manifest. So first line goes cd ... If you're new to that command, just know that cd ... is the command for taking you back up a folder. Run pwd in your terminal, which prints the working directory. As you can see, our terminal is still in NextWork Flask backend, the application backend code we've pulled. To exit this folder, run cd. Cool. And then you can run pwd again. Print working directory. Great job. You're back to the root, the starting place of all the directories in this EC2 instance. Cool. Then you run a second command to make a new folder called manifest. Navigate inside that folder. If I press pwd now, I am inside the manifest folder. When you're inside the manifest folder, it means that the files you're about to create inside are manifest files. Manifests are so important for deployment. Manifests are really that instruction sheet that gives Kubernetes all the information it needs to know, like what your application needs, which containers it should be running, how many copies of an app it should be creating and running at the same time. Now, that means without manifests, Kubernetes wouldn't really know how to set up and manage your app automatically. What is a Kubernetes manifest? Oof. Kubernetes manifest for Kubernetes on how it should deploy our app. Manifests are helpful because they reduce manual work when we're wanting to deploy and manage applications across clusters, across, well, really multiple containers. Done. Let us create the first deployment manifest called Flask deployment. Let us run this and see what it says. Oh, I just realized what this line is missing is the EOF command. So if you're seeing this over here, this means that there is something missing from this command, and it is the EOF. Let me update this so you can see. It should look like this. You have your cat, your spiky bracket, and the EOF. Before you have Flask deployment and so forth. This is something for me to fix on my end once we figure out how we can actually set up EOF in a way where it doesn't disappear. As confusing as that is, for now we'll move on. Cool. We have cat EOF, Flask deployment.yaml, and we gave it some commands, but I have a bit of a problem. No such file or directory. It seems to be telling me that it doesn't have a way to create this file from scratch. I'm not too sure why it would say no such file or directory. Maybe if I run ls in manifest, am I going to see anything? Cool, nothing yet. So no files have been created in this folder. There shouldn't be any conflict with other YAML files. I wonder where this issue is coming from. That's okay. I think in the meantime, I will be solving this in a separate way. You can still use this method to create your Flask deployment YAML file, but if you're stuck like me, you can use another method called touch. So you can go touch in the command line, touch deployment.yaml. Cool. So now if I were to run ls again, a file's been created. Touch creates new files. What should we do next? Create this file to deploy our app with Kubernetes. Another way that you can edit the contents inside a file is to use a tool called Nano. So Nano flask deployment.yaml takes us into this new view in our terminal that shows us how we can write and edit code that goes into files within the terminal. So powerful. Now that I'm here, I'm going to start by pasting the contents that was inside Flask deployment so that I can paste it here. You can use your keyboard to scroll up and down the space here in the top left hand corner so that you will get to see different parts of the same file without it having to be cut off, which is a great thing about Nano. What is a deployment manifest? Because we don't have a full understanding of what this manifest file actually means yet. When you deploy an app with Kubernetes, Kubernetes' job is to set up and manage several copies of your app, and it will set up different containers in the cluster to handle all the traffic and requests coming into your app. Now, a deployment manifest are the instruction sheets that tell Kubernetes exactly how to manage these tasks. They have details like how many copies of your app should run across your cluster, which settings you want to apply, like CPU limits. Maybe you have some sort of container image that you wanted to show. Maybe it is network settings that you want to show as well. But the good thing about a deployment file is, as complex as it can be, as customizable as it can be, it also does a pretty good job of staying relatively simple for newbies. Cool. Let us run the command where one of the students must have submitted a question that asked, how does this command actually create the deployment manifest when we launch that new folder? If cat doesn't work in the terminal for you, you can always give touch a go and let us know if it works for you. Now that we're here in this terminal, we can share that this software can work not just in the Flask deployment file, but in kinds of files you choose to open and edit using Nano in the terminal. Cool. Just a heads up, Nano I don't think is available on Windows or Microsoft. So if you're using that OS, just know that maybe you will have to use an EC2 instance running Amazon Linux 2023. One thing that caught my eye, scroll down here almost to the end and see there's a placeholder for that container image. Replace the URL that's here, the ECR image URL here, and just put in your work in there. So what this could look like is, for myself, I'll be deleting everything here. And then, very nice, we'll just be heading back into the Elastic Container Registry page, select the latest image to deploy, and then use that actually to replace the image's URL. So let us just copy that, or really you can just copy the image URI. Once you've copied it, you can actually go all the way wherever you find image in the container section at the last part of your deployment YAML file. Paste the image here. If it gets cut off, use the arrow keys to see the start when saved. Take a screenshot of your work before we close it up. Take a screenshot of that updated deployment manifest. You can choose whichever part you're proud of, whichever part you've customized. Take a screenshot of it. And let's add that to our documentation. I wonder how it'll end up looking. What does a Kubernetes deployment actually do? The rollout of container images, that could be a specific region, that could be the user who finds the app, as long as the app is made available to someone that is just using their phone or just wanting to visit a URL. That was a successful outcome. More important is to understand what a Kubernetes deployment manages. The Kubernetes deployment is about managing several copies of your app across containers in the cluster. A Kubernetes deployment manages multiple copies of the same containerized backend. The container image URI is more accurate. And our deployment manifest, the container image URI in our deployment manifest tells Kubernetes what kind of container, or tells Kubernetes the attributes, the container, that we'd like. Kubernetes to deploy. Press Ctrl S to save your work, and then you can press Ctrl X to exit things out. Once you're exited, it goes straight back into the normal terminal mode of sending commands. Alright, so next up is the service manifest. We've done the hardest manifest file. This is a simpler one to round off today's project. The service manifest will tell Kubernetes how to expose your application and route traffic to it. The step will create the service manifest that exposes our backend to its users, because it needs to happen for our backend to communicate with others and perform its intended purpose. And deliver on its intended purpose. Very cool. Only one command for us to run. Notice how we seem to be missing that EOF thing at the end of this command. Something for me to look into, and what we'll need to do is borrow that early part of the command that says cat. Okay, give it another spiky arrow and write EOF like this. Once that's done, you can copy the rest of the command here. Very nice. Cool. No such file or directory. Something for the touch up after this demo. Apologies. In the meantime, I will do the manual copy of this Flask service YAML file and create it. Let us run touch Flask service.yaml. Once we're inside, we can run nano. copy some key lines and paste. That is the service manifest. It's a lot smaller than the deployment manifest. The service manifest has a straightforward job for this backend application. Maybe it wouldn't be the simpler file for more complex applications. That is, luckily for us, ours is the most straightforward. A service in Kubernetes is like a traffic controller. It makes sure that traffic gets to the right pods inside your app. When you create a Kubernetes service, you're essentially exposing your application, making your application accessible to network traffic. Instead of just your application being accessible to traffic from the Kubernetes cluster, you can now actually make your application accessible to traffic coming from outside the cluster. This service manifest is how we want our service to do. When creating a service using that manifest, we give it details like, these are the pods you need to be routing traffic to. This is the kind of traffic you should handle, the kind of ports inside the container that you should be using. And each of these terminology, again, you'll explore in the secret mission or in the next project file. In our case, the service manifest routes external traffic to port 8080. Notice how port 8080 is mentioned in the port and target port. Any traffic that hits 8080 for our cluster will be directed straight to our backend application that we've set up. So what is that true difference between the deployment YAML that you saw and this service YAML that we've created just now? Don't forget, the deployment manifest is about deploying and managing your app, while the service manifest is about exposing the app to the outside world or other parts of your systems to create a fully functional application setup. It is satisfying to know that both of them need each other for the deployment to be considered successful. Cool. Let's take a screenshot of that service manifest. If I zoom out, will I see more? No, that's okay. We can take a photo. Let's take a screenshot. Very nice. Let us upload that screenshot into our project guide and then answer 2 questions about what a Kubernetes service does. Great stuff. So Kubernetes service exposes our application to network traffic. You need a service manifest because the deployment manifest takes care of creating, managing the application. Except how users or other apps will get access to them. And no service manifest. No traffic. So close. No service manifest equals no traffic. What does your service manifest say? This is your chance to revisit the helper text on the service manifest, highlight it, and ask for it to be simplified. Simplify here is saying the code defines a service named NextWork Flask backend. That's true. It uses the node port type, which means it exposes the service on a specific port on each node in your cluster. That is also true. This is something that we'll be bringing in more advanced projects. This allows you to access the service from outside the cluster. True. Once you use the node port type, it definitely does mean that there are more entry points into the application. These entry points are managed properly, and that's why the service exists. There's something called a selector, but we won't go into this in detail yet, like the certain terminology you're seeing, until this is all going to be a lot clearer. I think about having some sort of gallery that will collect all of the terminology you might come across in this series. Gallery of definitions at the end. Let us know if this is something you'd like. My service manifest sets up a node port and it maps traffic to port 8080 of a container running the application. Once the service manifest is done, we've ticked off the 2 major milestones for this project. You've learned how to create your manifest files, which is huge. Now, before we wrap up for this project, the secret mission is something that we do highly recommend, because this secret mission is all about the details of your manifest files. And you get to share, an annotated version back to the team. And the cool thing about this is the fact that you're diving into the details of your deployment manifest here. When you're ready, select the option to jump into your secret mission, and it's unlocked. So what are we doing in the secret mission? In this secret mission, we will dive into the details of our manifest files, especially the deployment manifest. Understanding the details builds a much stronger understanding. Select done to get that uploaded. These are fantastic concepts to learn. You will gain a deeper understanding of Kubernetes. You can make it easier for your team to work with these files in the future because they're commented, so there are short explanations about what each line means. These are new concepts and explanations. Doing new things is a part of the learning journey. It's supposed to be a little challenging. You've got this. We can go through it step by step together. So, we're just going to be taking that closer look at the Flask deployment YAML file. So we'll open it again. To head back, press Ctrl X again. And then we'll need to save our buffer, which means if you'd like to save the work that you've edited today, when you see the file name to write, keep the file name and press enter. All done. And then print your working directory. which is basically how you can see that you're still in the manifest file. That means you're still in the right place to see the deployment manifest. So we'll copy the code for the deployment manifest, put that in here. Cool. You can see the initial work on the deployment manifest is still here. So I really like it, the fact that I come here and I can still see that my container image is what it was earlier in this project when I first set it up. So very good. Now that we're back in our deployment manifest, we are ready to go line by line to break things down. That first line, API version, is actually about which version of the Kubernetes API you're using to create this resource. Since we're defining a deployment, this API version falls under the apps folder, which is why it says apps. If you're new to it, just know that an API is a way for, in Kubernetes, the API is how you tell Kubernetes what resources to create, update, delete. We can create the API version of apps/v1 because it's a way for us to provide feedback as well. Cool. So other options for the API version definitely exist. Things like security and storage. To annotate, move your cursor to add comments to the end of each line. To add a comment, press a space between the command and the comment. You can add this little comment that we've prepared for you today. So let us copy that, paste that here. And here we go. We've set it up that this early line is all about specifying the API version for this deployment. Cool. If you see that little hash icon, just know that this is a keyboard character we'll use to add comments in a YAML file by other kind of text processors, just depending on what kind of rules they follow. In this line, you can see we use a comment to explain the line, what we expect to happen, or if there are any errors, something you want to caution people about. That's also something you can use comments for. Cool. And that was the first comment down. That was fast. The next line is the kind attribute which got deployment. There are so many different kinds of EKS resources you should be creating, which is why when you have a deployment file, you'd want to be clear about what kind of resources we're wanting to make an ask about. Entering deployment like this is very helpful. At the end of that deployment line in your file, you can add a comment. The comment can be, this is a deployment object, and that's a valid comment. As you might imagine, there are a lot of different things in a file that you can annotate. It seems like over here, we're feeling confident on doing 2 lines at once. So let's do that. You can see that these 2 lines says metadata and a name. So what is metadata? And metadata is all about the details of the resource itself. So in our case, we are wanting to deploy our containerized backend. And as you can see over here, we want to name that NextWork Flask backend. When we write our comments, you can go hash metadata contains metadata, for example, name, labels to help us organize. Resources. If you see a line disappear, it's because the line has grown to be a bit too long to be a single line display, which is when it goes into 2 lines, it looks a little bit more confusing compared to its usual format. Oh, there's 1 extra line. for the deployment resource. And I'll stop here. Great. That was very successful. We added 2 more comments here. And let's keep on going. So we even have something called a spec later on in this file. Spec is one of those things where you don't realize that it's very important until later on. So I'd recommend taking a closer look into spec and what you think. Cool. So you can think about spec as the blueprint for how Kubernetes should set up and manage the deployment. You're going to see the term spec again in the very same file. When you see spec for the first time, which in our case this is our first time, just know that this is probably the bigger blueprint that's being created here. And in this case, this is a bigger blueprint that's being created because it is a template, or it's a blueprint for setting up and managing the entire deployment. So it tells Kubernetes things like what type of containers it should use, how many groups of containers it should be running, any special configurations these containers need, anything you would say is part of the desired state of your Kubernetes cluster. If it was running perfectly and it can't get any better, what will each container look like? Maybe that could be the desired state you set up. Alrighty, next to spec, you can mention that spec is specification. A blueprint for the entire deployment. Great! We've added a new comment to spec. Pretty neat. We're really making our way through it. Next up is replicas. It's a huge topic. Replicas are identical copies of the app that Kubernetes should run. We're asking for 3 replicas, but it doesn't mean there are only 3 copies of the application or the image that's running right now. Because when you set the replicas to 3 and it's running, it's really about how many pods are being created, and these pods will be running the application inside. So the deployment is truly responsible for making sure that if even one pod crashes, a new one is created to maintain 3 replicas in total. So you can see that we have a replicas 3 line inside the Flask deployment file. Cool. So anything under that spec section over here is going to be treated as kind of like the golden state of our deployment. So we'd want our deployment to hit these stats as much as possible. Cool. We've mentioned the pod a few times. A pod is like what you'll see if you look at your Kubernetes cluster under a microscope, zoom in, and it's one big group of containers bundled together. A cluster contains containers running the same or related applications, and there's a concept of nodes underneath it. Okay, so once you've zoomed in as well, you've noticed that there are nodes, and you'll notice nodes even more you'll see that inside nodes are pods, and there can be one pod inside a container. Inside a node, it can be multiple pods inside the same container. It really is up to how fast you want each of your nodes running. In Kubernetes, think of pods as groups of containers that are bundled together so they can work together as one unit. Pods are truly the smallest things you can deploy. You can't deploy containers on your own. They must be inside a pod. Pods are the smallest deployable units in Kubernetes. Kubernetes will deploy a single container by itself. Pods exist for speed and efficiency. Containers in a pod share the same network space. They also share the same kind of storage and the kind of data that they want to keep. So the pods in there definitely are using the most out of having shared network space and storage. A notable line in the deployment manifest is the number of replicas, the number of copies of our app we'd like to deploy, across our cluster. Pods are relevant to this because 3 replicas equals 3 pods. There's like a one-to-one relationship. Deployment needs to know how to create pods. There are different variables in this deployment file: match labels, template, and then under template there's metadata, there's labels, spec, containers, and all the details around the containers as well. Very cool. So we'll go over these in a higher level. The most important and the most detailed parts are behind us. The cool thing about the selector is you can think of the selector as a filter. Only pods that match the conditions here will be used in deployment. What are those conditions, you might be wondering? So one of those conditions is match labels, which means a pod must have the label they cannot be a part of the deployment if it doesn't have the right label. That makes it ready for deployment. That is something new we've learned about match labels. After match labels, it will actually show you the label required for a pod to be used in deployment. I think that's it. Hopefully I can navigate through my console fine. I'm not too sure where those characters came from, but I'm curious. I just realized I need to scroll this way, but I was very silly enough to accidentally be deleting some actual parts of this template, which we're fixing now. That looks better. We talked about the match labels. Here we're introducing another section called template. Template is the blueprint for the pods that this deployment will create. So the deployment, when we say we're creating a Flask deployment YAML file, what's really happening here is we're creating a resource that's called deployment, and that resource will be helping out with all of the deployment related activities. So we're here to define what is going on in terms of the template for each pod. How many containers should the pod be running? What is going to be the container image that the pods are running? So for now, we can write a little comment that says the template is the blueprint for pods that the deployment will create. Very nice. And metadata outlines the metadata for each pod the deployment will create. The labels here will be inherited by all the pods the deployment will create. All pods created by this deployment will have this tag. Very nice. So once you have figured out that all pods created by the deployment will inherit this label, it makes sense why we had a spec section for the entire deployment. But that entire deployment did mention that we'd only be working with pods that have this label. What's happening here is knowing all pods created must have this certain level for the deployment resource to take on a certain app as a part of deployment. Otherwise, the app wouldn't be deployed. It makes sense why the template section would include that every pod you create will have the exact same label that this other institution values. So maybe there is something to be said around how match labels and labels will connect the pods you create through this deployment with the pods that you've set up, with the conditions that you've set up, that only pods that meet that certain criteria can be a part of the deployment. Very cool. Very nice. The cool thing about having that template section is once you have this blueprint for pods that the deployment will create, when a pod is no longer available, Kubernetes will use this template to say, okay, it's okay, something's gone down, but I know exactly how we should be building replacement that will be running right away. This template is quite important. It outlines how one pod will look and behave, but many pods, however many times this template will be used. Cool. So you can add your comments to the template section. The spec section finishes off with a bang, to be honest. There's lots of great learnings in here too. But I'll take a minute, as I understand that there's a lot of new information in that just now. Take a breather and play this again when you're ready. So we've arrived at the pod level spec, which means shift in tone. This spec defines the desired state for every pod inside. If a pod doesn't meet the standards, it can be removed and replaced quickly. To emphasize, there are two spec sections. This spec is the blueprint for the individual pods that the deployment will be creating. And if you're wondering what's that difference between spec and templates, just know that the spec is about the operational details of the pods themselves. The template is about operational details. It's covered under spec, but also other things like metadata, like labels and names. So both are very similar in that they're templates, but you can think of spec as one that falls underneath the definition of templates overall. Templates is a much, much bigger goal that we'll be working towards. Cool. Let's take a screenshot of the comments for pod, which reminds me, I think I've just been talking so much, I haven't written my comments. This is the pod level spec section. Cool. Let's take a quick screenshot of it. Saved it, so it's easier to drag it in like this. Let's try dragging it in again. Oh, okay, it's all working now. Great, done. And we've reached one of the last sections of it, which is containers. And containers define what is actually running inside each pod. Now that we know the desired state for the pod, that's what spec is about, we know that containers is what's actually running inside each pod, the actual app. Let's write the comments or annotations for the first half of the container section. Containers are about what's running inside each pod. Cool. There's a section for the name, but really the most important part about this one is that you get to provide the container image that each of the containers will be running, and also the ports. If you haven't learned about ports yet, totally okay. Just think about ports as entry points that allows data to enter or maybe to leave an application running inside a container. A port is kind of like this specific entry point that you open or that you allow your app to continue tracking and noticing and watching out for traffic, so that when it enters, it gets routed to the right service that's ready to handle new users. And I think that's the biggest thing about ports. If your container is a house and the ports are doors, each door leads to a specific app or part of an app. In our case, we are in the part of an app bucket because I am only deploying the backend. In Kubernetes, a deployment manifest can actually be managing multiple different kinds of ports and multiple different kinds of connections. But our solution will just be keeping it simple with only one port, which is the container port. The container port is used by the app inside the container to send and receive traffic. Here our backend will listen on port 8080, this container port here, which means it's ready to receive requests sent to that port. requests need to specify the correct port to reach the app. If a request is sent all the way to your cluster, but it sends the request to port maybe, let's say something random, like port 22 for SSH traffic usually, then maybe the app won't actually receive your request because it's not going through the correct port. That's how important ports are. Now, if you are interested in how requests end up at the right port, you can know that the reason for it is a mix of DNS and IP addressing, port numbers in the request, or because of the services in Kubernetes, which is all thanks to the service manifest. Cool. What's happening for our container port? Is that the app inside the container is watching out for requests coming into this port. Once that's all set up, you have most of your comments written in now. That is your deployment manifest all annotated, which is something to be proud about. Notice how as we move down the deployment file, you are actually just going from a very, very high level of what's going on in the Kubernetes architecture to the container level. The container level is at a smaller scale compared to the API level, but equally important, isn't it? So at the very top of this file, we were interacting with the Kubernetes API, which is this interface that lets us define resources. At this level, we're telling Kubernetes, hey, I want to create a deployment using this version of the Kubernetes API. And then after that, you're looking at this big picture setup for the entire deployment. So how many pods you need, how Kubernetes should be maintaining all of this. So that is the template or the spec for the deployment at large that you can find here. That starts with spec, that deals with metadata, the name and the namespace, because it looks at the details of the deployment with specs. You see the level of detail for templates at the deployment level, which is a completely different game to these kinds of deployments at a more startup or a small team kind of level. And you will notice that as you move deeper, you reach the template section at the end. This template section is the blueprint at the pod level. Now that you have your deployment, you know the desired state of your deployment. You can mention the desired state of your pod inside your node. To define the desired state for a pod, mention the container running inside the pod. Containers are the core of each pod, where the actual application lives and runs. Our container section defines the image and port of the app that's inside the pod. So the container section, however small it might seem compared to the other sections, determines a lot for our pods. So quite an important one, this one. Cool beans. I think we are at the finish line now, so we'll just finish off this secret mission by mentioning a quick reflection on annotating YAML files. Annotating YAML helps me understand the ins and outs of each command in the deployment manifest, because you are breaking down and explaining each line. Their relationship. Is there anything unclear about the manifest? One part I still want to know more about. Is the namespace of a deployment, because it's not too clear, and how it impacts deployment. The namespace is closer to the top under metadata. How it impacts deployment or how it's used as metadata. That's also something that's a little new to me that I'd like to know more about. Very well done. The deployment manifest describes the desired state of your application, those true concepts of Kubernetes. So well done for going above and beyond, doing the secret mission, understanding every single piece of your deployment manifest. Let us delete our resources for today's project. You can delete your cluster first and foremost by going in and deleting your cluster within the terminal this time. So last time it would have been with the console, but actually try using just commands this time to delete this cluster. So you can quit your work, press Ctrl X. It's up to you whether or not you save this buffer. If you want to save your work and you comment somewhere, please make sure that you copy and save it somewhere else, because we'll actually be deleting this EC2 instance, which effectively deletes all of the content that's inside this file. So make sure to press yes if you want to save it. Otherwise, move on. The command here is to delete your cluster. Let's go ahead and delete it. Oh, and it says the AWS region must be set. I'll just note that down for a second. So let's say EKS delete cluster. It should be -- region. Leave AWS East 2 where Ohio is. Let us use that as the region. Alright, it seems we can't get a role ARN for the current session, so let us just try to refresh this and understand whether or not this is something that's simply a case of our session expiring. Maybe not. That's okay. Let us head into CloudFormation to see whether there's anything fishy going on with the resources that we've created, the cluster we've created. At least the CloudFormation way to delete it is always available. So we can select the first stack and delete that first, which effectively deletes all of the resources inside, which is so handy. And let us delete the entire cluster as well. While that deletion is in progress, you can head to your EC2 instance and start to delete the instance that you're using to manage all your classes and commands. We don't need it anymore. We can always set up a new one. So just make sure you can change the instance state to terminate it. You can delete it instantly like this. Very nice. What's next? Is there anything I'm missing? The ECR repository. Head over to our container registry over here, and then make sure that you delete the entire repository. You don't need it anymore. So select delete. This should delete all images inside. It's gone. That was fast. Let's write a quick reflection. I used Amazon EKS, EKSCTL. We used Git. What other tools did we use? We also used Docker. We used ECR to create a Kubernetes cluster and build the container image up to deploy. Key concepts include using manifest files, deployments, and services for Kubernetes deployment. Very nice. How long did it take you to complete this project? This project took us approximately 2 hours, including demo time. The most challenging part was, what was the most challenging part? What would your vote go for? I think my vote for the most challenging part would be understanding breaking down the deployment manifest, my favorite part was being able to set up manifest files and understand how it works. So the most challenging and the favorite part are really one and the same. Thank you so much for doing this project today. Why did you do it? This project met my goals because I wanted to understand Kubernetes deployment. This project made me understand deploying a cluster, building a container image, etc. And the fine-grained details of manifests. All done. Task done, which is amazing. Well done, everyone. Something to be extremely proud of. And that's a wrap. You've deployed the backend of an app with Kubernetes. Awesome. Give yourself a pat on the back. You've learned to build and push a container image of the backend. You also learned to write manifests that tell Kubernetes how to deploy the backend, which is true. Deployment manifest and service manifest, very important files that tell Kubernetes how you like to deploy the backend. So I'm really glad we got to learn that together today. Shall we go check out what you'll be doing in the next project of this series now that you've set up your manifest files? You'll be able to actually use a new tool called kubectl to actually deploy the backend and turn it live. Very cool. So cool to see always. This feeling doesn't get old. The feeling of all of your work collated all together in a documentation is just so cool to see. And it is also awesome to see the way that all of your screenshots are formatted quite nicely, and your work is also always in formatted pages so that someone reading your work will see a consistent storyline of what you were doing in this project. Very, very cool. I hope you enjoyed this project as much as I did. I surely did as well. Since you'll be able to see a little pop-up panel that lets you share the project on LinkedIn, please give that a go. Share the project on LinkedIn, use the LinkedIn post template and post that right away. Truly, truly hope that you are feeling extremely proud of yourself for what you've achieved in this project, because it is not easy work at all. It is getting harder with every project in this series. You might be feeling a little bit of the heat, but just know that you're doing an amazing job. Thank you so much for spending time on this project. We can't wait to see you in the next one and appreciate the support. Ask any questions you might have in the community. We'll always be there to help each other out. See ya!